So now let's start this question is a high level question. So I think this video is last video I made this night. Now let's see the question. You are given a binary array now and an integer k. The KB flick is choosing a subarray of next k from nouns and simultaneously changing every 0 in the subarray to 1 and every 1 in the subarray to b. So return the minimum number of KB flicks required so that there is no 0 in the array. If it's not possible, so to return -1. And the subarray is contiguous part of an array. Now this one is example. So the subarray of k, so we just take this one and this one. So here all the number become 1. So we just take 2 times. Now here is k, the window should be k, size of k, right? So now the first two, we will select the first two number. So we know the window, the number in the window are 1, right? We don't need to do anything. Now we select here. So we find out no matter how many times we perform, the flip is still a 1 become 0, 1 0 become 1. So we cannot get the all 1 in the array. So here return -1. Now I would say this question very tricky. It's really hard to explain the logic behind the scene. So I try my best. So here I use this example to explain my this logic. Now here, so now if we have 0, so how many times the 0 will become to 1? So we know we need to flip the 0 just 1 time or 3 times, 5 times, 7 times is all time, right? We can flip the 0 to 1. And 1, we need to even flip, right? Even if we flip, we do not need to flip this one because 1 already 1, right? Or we need to flip the 2 times, the 1 still be 1, still be 1, yeah. Now, just like these two statements, we need to add all time flip in the subarray. Our case, if needed, multiply 2 equal to current value. Now here, the second statement is even time flip. Now, let's go to next. So here, we have point. We have 3 variable here, k. So we know the subarray of k, right, side. So here should be a 3 element in this window. And the conflict is, you can understand the conflict is the result. We need to, how many times we flip. And then the lead flip, we need to count the lead flip in a given subarray, right, of k side. Now here, we use this formula to get now how many lead flip we need to do in a given window. And then so now pointer will here flip. The flip array mean is just easy to keep track of the current value need to be free or not. So it's Boolean type. So you can initially all the elements should be full. Now we have pointer point to both array in index 0, right? Now when we point to the first index, we need to use the formula. So now the 0 is the lead flip. Now you can see the lead flip is 0, right? 0 multiplied 2 equal to the second 0 is the current value. So current value is equal to 0. So now, do we think is true? Yeah, right? So we got the true, which means we need to flip the given subarray 1 time. Now the flip will become the true. The flip become the true. It's just easy to keep track of. Okay, in given subarray, we need to flip 1 time. And you can see lead flip equal to 1, and the total flip also equal to 1, right? Now we need to expand the window. So now the window has two elements still valid, right? Because the k equal to 3. Now we're also using the formula to find out the needed currently needed is equal to 1. 1 multiplied by 2 equal to 0. No, right? It's no, so we don't need to do anything. We just expand the window. Now the subarray is still valid because just 3 elements in the window. So now we do the same thing. 1 multiplied by 2 equal to 0, right? It's not 2, it's 4, right? So we didn't do anything here. So you can imagine the first 3 elements we just free one time. The 0 will become to 1, right? So let's make sense, right? Lead free equal to 1. So you can understand here. Let's make sense. Now we keep expanding the window, but before expanding the window, we need to check the window is valid or not. If we're adding this one to the window, now we have 4 elements, right? So now before expanding the window, we need to narrow the window from left to right, and then we can add a lot of elements to the window. Now we narrow the window, and you can see periods. The periods is 2 because we narrow the window. So here the 2 should be become the 4, and then need 3 should be 0. Need to decrease by 1, right? Because we don't need to free these elements anymore. Now we need to expand the window to. Now there are 3 elements in the window. Now do the same thing here. Let the freak multiplied by 2 equal to current value or not. So now you can see let free equal to 0, right? 0 multiplied by 2 equal to the current value or not. No, it's not 2, it's 4. Now we don't need to do anything. So now doing the same thing here. We need to check the window. If we try to expand the window, it's valid or not? No. Then we have 4 elements in the window. It's not valid. So we need to narrow the window, and we need to check the here in the top. The current top is in the F, right? The one is F. So we don't need to do anything here. So we just narrow the window. Okay. Now we need to expand the window. Now doing the same thing here, just net freak multiplied by 2 equal to the current value or not. I would say, okay, it's true, right? Net freak is equal to 0. 0 multiplied by 2 equal to current value or not yet. So we need to add, we need to freak, we need to make this 4 to the 2, right? And then we also need to narrow the window, and we also the lead freak need to increment by 1. Okay, right? This one is become true, right? And the lead freak equal to 1 now. Now we do the same thing. We just narrow the window before expanding window, right? So we also need to check the top of the value is boolean is true or false. If true, the lead freak needs to decrement by 1. If 4, we don't need to do anything. We just expand the window. Narrow window before expanding window. Now we come to here. So do the same thing. 1 is the lead free, right? 1 multiplied by 2 equal to 1 is current value, right? So it's 2. Okay. Now we need to turn the current status become the 2, right? And we also need to increase needed freak by 1. We need to do this both. Okay, you see the needed freak become 2. The current that's become true. So we need to freak 2 times in given array, given subarray. Now before doing the same thing here, just narrow the window before expanding the window. So we see it's 4, so we don't need to decrease the needed freak by 1. Okay. And now we come to here. It's a needed freak equal to 2, right? 2 multiplied by 2 equal to current 1 or not? No, it's not, right? No, it's 4. So now doing the same thing, narrow the window, and we find out, okay, the top of the boolean is true, so we need to decrease the needed freak by 1. Right? Also, we need to turn the t to 4. Okay, now we point to the last elements. Now we need to 1 multiplied by 2 equal to current value or not? No, it's 4, right? Okay, before doing the same thing, right? We check the top of the Boolean array is true or false. Is true, right? So we need to decrease the needed freak by 1, and here also need to become 4. And then now needed freak equal to 0, and here become to 4. So now we already point to the end of the input array. So mean here we just check the needed freak. Okay, needed freak equal to 0, which means we just return a 3 as the minimum freak time. It's valid. So all the number become 1. So now let's code it up. This question a little bit hard to understand. Hopefully you can understand. I try my best. Okay. Now let's code it up. Now we have needed freak, right? We also have the conflict. Because conflict, we need to return it. Oh, 1 second. Oh. Now we also have the Boolean, right? In the freak. Okay. What happened here? And now we need to do here, go to for loop. Now we need to go to the noun array. So if I greater than k and now freak equal to I minus k, so we know we need to delete this one because we need to narrow the window. If the top of free array equal to 2, which means, okay, we need to decrease the needed freak because the top number is not in the window, so must be removed. And then we need to do now needed, right? Needed multiplied by 2 equal to current 109. If yes, I will need to check I plus k greater than n. So we know we cannot free all the number into 1, which is negative 1. So now we just need it. And the count. Also, the current freak become true. Now we finish this one. Let's run it. Oh, hold on. What's wrong here? The issue should be here. Now you can see pass on the test case. And let's submit it. Okay. Even though not be 100%, it's still I think it's still efficient. So thank you for watching this video. Before I start recording, so the time complexity is b of n because I just go through each element in given array one time, right? And then space complexity is b of n because I use the actual memory here. I use the Boolean array. So thank you for watching this video.